4.8 stuff. Sir! That's what we're doing today. You had stuff from Tuesday and Wednesday. There was a mixture of 4.7 and 4.8 in there. I threw a couple of the...
Oh, come on.
Yeah, because that was the odd, because you had evens, the odds,
Oh, no.
and then yesterday. So yeah, we should do the 3 days worth of stuff. The majority of the stuff that's in 4.8 is all review. For example, it might say something like, solve the right triangle. It might say solve the right triangle if you're given something like that. And when you solve a right triangle, how many parts do you need to work with? 6, because there's 3 angles and 3 sides.
Correct.
So first we need to do is draw our diagram. Well, if I label that as A, B, and C, where C is our right angle, do you remember how you label the sides?
Little, like lowercase?
Yeah, lowercase. Where does little a go?
Across from.
Yeah. Remember the sides are always across from them? Okay. Sides are across from the angles, obviously. But they just use the same letter. So what happens here, if you're just given an angle and a side, you just start filling in the blanks.
Where is it?
I'm
Does
just,
it not
it,
matter?
it really doesn't matter, but I'm pretty sure the book will give you a generic diagram and just label parts off of it and you just reuse them. Sometimes it says triangle ABC is a right angle. It might say B is the right angle, then you just go from there.
Oh.
So if I'm doing this then, this is 20, right angle, and I know little b is 6. So I have to find little a, little c, and big B. What's the easiest thing to find first?
Angle B.
What is that?
90 and 20.
70. Okay. And now I need to find side lengths. And when I'm finding side lengths, I'm going to use good old-fashioned SOHCAHTOA. That's exactly my thoughts as well. Wow. Good old-fashioned SOHCAHTOA. How are you?
Very well, how are you?
I'm all right. Uh-oh. They're towing your car. Never mind. They're not towing your car.
Hard booted anyway, so.
Yeah, there you are. See you later. So, if I'm at the 20, and I always like to kind of reuse my givens. Those of you guys that have done trig before know that if you make one mistake and you reuse that side length or that angle that you found, will you ever get the next side length correct? No. Try to reuse your givens in this scenario so that way you use 2 different trigonometry functions and that way you have a better chance of getting them both right. Because if you get the first one wrong and you reuse the wrong part, are you ever going to get the next one right? No. All right, it's possible, but is it going to happen? Not likely. So what trig function am I going to use with an adjacent to find an opposite and then to find a hypotenuse? What am I using? Tangent and what's the other one? Cosine. So we'll do the tangent of 20 will be little a over 6, and the cosine of 20 will be 6 over little c. What I say by, do you remember the shortcut for when you're working for solving the denominator, excuse me. I know you guys have all done trig function problems for a long time. By now, you guys know that all you're doing is just switching them on that diagonal for the unknown when it's in the denominator. Yes, no, maybe so. That means C is going to be 6 divided by the cosine of 20. A is going to be 6 times the tangent of 20. It's little parts like that. Make sure your calculator is in degree, you'll be fine. Okay? The book has it going in radians quite often, and then it has you resimplifying it back to degrees. So I mean, you can do it that way if you want, but it's kind of a pain. What's wrong?
I would change
The tangent? It's A divided by 6. How do you undo divide? Multiply. So 6 times the tangent of 20. Yeah. Oh, it's a little A. It's a really little A.
really tiny. Okay.
Did you find it the settings? It's under, you hit the home screen, go to settings, and you just type. Yeah. It's easy. Now we don't have to do conversions.
How did you do that?
Settings? Yeah, go to settings and you scroll down, then it's in under one of those options, I believe. Okay. So that's one thing you guys have done. The next little quick blurb, which what you guys were working on yesterday, when you have the angles of elevation versus angle of depression.
Get all the way downstairs.
Jeez, good riddance to you too.
Does anybody else know if they're leaving?
Does anybody else want to leave?
I'll
Yeah.
Sweet. All right. So angle of elevation versus angle of depression. Angle of elevation is line of sight looking up. Okay. So if you're on the ground looking up, it's the angle off ground level. A lot of times line of sight problems come into play when you're literally line of sight. How many of you guys did the protractor, clinometer, protractor on a string with a paperclip thing in geometry? That's all this was. That was when you took it, line of sight, you're looking up, you had a string off vertical, you're able to figure out your angle of elevation that way, and you used the trig to measure distances. People that are surveyors, the guys walking around with a stake in the ground and they're just looking through something, they're measuring with trig. Hunting scopes, they are rangefinders, things like that. They are automatically doing those trigonometry calculations to give you distances by looking at a fixed point downward and whatnot. They're using angles of depression versus an angle of elevation for what you're looking at for line of sight stuff. We were joking last hour, geometry's doing this stuff right now. Lige had his phone out. I told him to download the app for the bubble. You know, and you think you were best playing the bubble game, but not the bubble.
Oh, no, I was
No. At least you're not driving. So what he was. So what he was doing is he took his phone and he was looking with it next to his eye level. He was looking down to the floor, the corner of the floor there, and we were trying to figure out the angle of depression because the phone goes off level and looks downward. It was 24 degrees. It's convenient because there's Lige. There's muscles, but he needs to do leg workout. So the angle of depression was line of sight looking down. Now the reason that line of sight down that's depression. Line of sight is always parallel to the ground. Okay? Bless you. So if you're parallel to the ground and you are vertical to it, you create a right angle. Two parallel lines cut by a transversal gives you alternate interior angles, which means line of sight down is the same as line of sight up. Angles of elevation and depression are congruent. They're the same angle. It's just one's inside the triangle, one's outside. Because it's very easy for us to physically have a tape measure on a horizontal or a vertical, but it's very difficult to measure a diagonal with a tape measure. You only go out about 6 feet, 8 feet of the good one, and then it just snaps, falls, you can't measure it. It's true. All right, the only time you can use your horizontal, or excuse me, your diagonal distance if you have kite string. Because you know it's fixed distance of a kite, you can buy a 100-foot roll of string, right? So if you go fly a kite and your kite gets stuck in a tree, you have 100 feet out, you know that your diagonal to the tree is 100 feet. And then you can measure your phone angle on the floor and you can figure out how far away you are from the tree.
Sounds
If it's taught. Sure.
I had a 200 snap.
Tomorrow's supposed to be a good day for kites. It's going to be like 40, 50 mile an hour winds. Do you guys have rollerblades or roller skates or a skateboard or something? Well, I would never have guessed. Get a big sheet and make a sail.
Done.
And go down the street.
Mark, you want to see like that?
That's
Yeah,
a different
right.
type of-
Oh, we're going to park lot where there's nobody here. Oh, that's right. Yeah, you don't have to apologize.
You hit it
So,
fast.
I know that you guys have all done.
I
I know you guys have all done elevation, depression. Just reminders.
I wasn't texting.
Wait, you played cat?
You're a terrible person.
I was going 55.
That wasn't a perfect situation.
Oh. You got the
Okay,
kitty
it's a
right
squirrel.
here.
You gotta be kidding me.
All right.
It's not like I did it on purpose.
Anyway,
Can we go back to math?
bearings. Bearings is the new thing for you guys today about how we can make triangles and do stuff like that. Bearings are used obviously for nautical. If you're on a boat, or if you're on an airplane, or if you're hiking, you walk for X amount of distance at a specific bearing, and then you change direction. You're able to figure out where you are. It's been around forever. It's just all kind of a standardized way that they measure degrees. Now, we all know that if you want to say something's 100 degrees, you would start at 0, come into the second quadrant, and go from there. That's how we've been taught to place angles within the coordinate planes and whatnot. But if you use bearings, this is where it gets slightly different. Bearings are always measured off a north-south line. So bearings are measured off north-south. So what you do here is you say that if you are south, oh, okay. I should preface this that I think you guys know how to draw a never eat soggy waffles.
Or sour bed.
Sour what?
I actually thought it was the other way. than west.
Watermelon.
I thought it was.
Never eat soggy waffles. I'm assuming you guys know that.
Yeah.
Okay, let me ask this. Close your eyes and point.
Oh no.
North. Is that what?
Don't do it.
Close your eyes
That's
and point east.
Hey.
You're the only one that did that. Great. That's great. Yeah, that was east.
Gosh darn it.
Then your compass is wrong.
That's the west.
So, if I want to say
Did
north
they close their eyes?
30 degrees
Ew.
east. That's priceless. If I want to say north 30 degrees east, what I'm starting with is you're going to go 30 degrees off of north towards the east. That means this angle here is 30 degrees. The first letter tells you if you're going to be up at the north or the south. The last letter tells you you're either going to be going east or west. The number in between tells you degrees. All right. All right, let's try another. If I say south 45 west. If I want to say south 45 west. I start at the south. What's the next letter that I'm going to go? West, and I go 45 degrees. Okay. It's counterintuitive from what you guys have done in the past because everything we've ever done before always had reference angles, and reference angles always bounce off the x-axis. These are bouncing north and south. That's all. Okay. Oh, I spun this the wrong way. I'm sorry. This arrow should. I should do it this way. Excuse me. Okay? Tell me that's off. Does that make more sense? The other one that, if it says it like this, unless you're in an airplane. If you're in an airplane and they're talking about degree measures, they're just going to say specific degree. Well, airplane degrees always start north, and then you just go however many degrees it is. Think of this as your 0. So if I'm in an airplane, I'm going 70, or if I'm going to go 135 degrees is my bearing while I'm in an airplane. Well, this is 0, 135 would be here. Okay? Not really, because I'm in an airplane. So if I'm facing north, go north, and I want to go 135 degrees, let's see, so then I'm going to go, I'm facing north, I want to be at north.
Oh, and then you
So
want
I'm
to
going
turn.
that way.
Oh, actually, pretty sure.
Because
That
north
way.
is, yeah, that way, so that's why I was
Like
facing north
face
at first,
south.
like, no, I want to start at north, my back to north,
Why?
Because that's the way you're going.
because you start at the 0, and you're coming out, so you're moving,
So wouldn't you be looking north?
No.
No, he's turning.
no, because I'm starting there, my angle starts at 0 at north, and it works its way down. So in essence, basically what I'm doing here, this would be what, 45 degrees, no, 80, can't use my head here, why not? Oh, it's 45 degrees. So this would be south 45 east.
I still don't get why you're
That's 0.
Because this is where I'm, all right, if I just said, draw 135 degrees here, you'd start at 0
Yeah,
and do this. Okay,
I get that.
well, this is angle measure stuff. This is not, or this is now airplane stuff, but it doesn't go counterclockwise.
I don't get why you're back to
Because it just, you don't have to, it just
facing.
makes
It's
it
just the way
easier.
the cookie crumbles.
It's just the rule.
Yeah.
If you're starting at 0, you start at 0, and you're going to go 135 degrees, you're doing that. So this is 0 up here, 135 is there. That's just how they came up with it. That's all. It's just a standard in aviation. That's it.
Yeah. Did he teach you everything he's ever
Oh. That
Yeah.
So let's look at this one. There's a couple
How
of
many
terms.
airplane ones are there going to
I don't know. Bearing, I'm just showing you the differences. This is the one that takes a little bit of time to talk about. A ship leaves port at noon and heads due west at 20 knots or 20 nautical miles per hour. A knot was a way that they figured out how fast they were going by tying knots in a rope and just watching how fast they were going past the boat, and they would count it. As a way over a specific time frame, and they did that. I don't know how it worked. It did. It's crazy. I just know what a mile per hour is. A knot is a little bit slower than a 1 mile per hour. 1 knot is a little bit slower. I think 20 knots might be 17 or 18 miles an hour, somewhere in that neighborhood. Rough, give or take. So what happens here is, if you think about you're starting at a specific location. If you're starting at a specific spot and you're heading due west, this is where it comes back in the idea that you guys know what that is from a given space. So if you start here, which way would due west be?
Left.
Okay? Because when you're looking at it, this is due west. Okay? You went due west for 20 nautical miles per hour for 2 hours. How far did you go? 40 nautical miles. Everybody okay with me so far?
Yeah.
At this point, you went north 54 degrees west. So that means there's a bearing thrown in, which means we put in our little we throw that in there. And it said 54 degree north 54 degrees west. So which way did I turn? I turned well, yeah, I made a right, but I'm coming up this way now. I came up 54 degrees off that vertical. Everybody okay with that? It's off the vertical. All right. You went for another, I think it went for an hour. Yeah, so you went another 20 nautical miles. And now you are here. You started at point A. You changed direction at point B. You ended up at point C. How far are you from the start? Okay. Now, it really just works out to be some quick right triangle trick, believe it or not. There's two right triangles.
Is that one supposed to be right here?
Yeah, because what happens here is I can draw this
Oh,
to that.
I thought you
Ooh.
You got the bacon? There's someone at the door.
And I'll call that, oh, okay. So now you have
I didn't know we could.
this specific distance further west and a specific distance north, okay? We know the hypotenuse of that triangle. Well, if this was 54 degrees off vertical here, what's left now for the inside of that angle? Very good. So I have 36 there. 20 is my hypotenuse. What trig function is going to give me my opposite? What trig function is going to give me my adjacent? Sine and cosine. So I have the sine of 36 is going to be my opposite over my hypotenuse. Cosine of 36, my adjacent over the hypotenuse. Now remember, this is my adjacent, this is my opposite. Some quick button pressing. The cosine gives me 11.76, and, oh, sorry, 16, excuse me, 16.76. The other one is 16 point, the cosine is 16.18, I'm sorry, I'm reading the wrong line, and then the sine is the 11.76, excuse me. I did it too fast. Now, do you know your overall westward distance? What is it? 56.
Oh, that's fine.
Yeah. 56.
68. Oh, it's way up.
That's it.
And this vertical is 11.76. Now, isn't this distance here just the hypotenuse? Put that right there. So you add them together, take square root, and that gives you your distance from port. .4 nautical miles. That's how the bearing works. You're just creating right triangles out of it. You're creating right triangles out of it, you're using SOHCAHTOA, okay? You want to do another one like that?
Yeah.
Really?
Oh, Jenna, it's easy. In your book, I'm going to do 31. A ship leaves port at noon and has a bearing of south 29 west, and it sails at 20 knots. This is 31 from the book. I think I have it up here. Oh, I X'd it out. Oh well. Anyway. So you start, it goes 29 degrees south, 29 degrees west. What's that? So I start at south, and I go towards the west, 29 degrees. 26. Okay. It does that at 20 knots. How many nautical miles will it west will the ship be at 6 p.m.? Well, if it left at noon at 12 knots an hour, how many would it go? 6. 120 nautical miles. Okay? So you have 120. It wants to know how far west it's been. Isn't that your west? Okay. What trig function are you going to use to figure out the west?
You are going to use
Sine. So the sine of 29 is your west over 120. So it's 120 sine 29. That's how far west you are. .18 nautical miles west. Okay. At 6 p.m., the ship changes course to due west. So it changes course at this point and goes straight west for an hour. What's that little distance then? It's still 20 nautical miles an hour.
Oh, we're going 20.
Yes, we're doing 20 now. We're speeding it up. We have 3 motors on the back of our boat instead of 2 now. And find the ship's bearing and distance from the port of departure at 7. So they need to find now the distance from port. Well, first of all, we got to figure out, excuse me, we got to figure out some angles. Well, if we're trying to figure out the angles then, that's going to be this angle here. You okay with that? All right. So we know that that angle has an opposite. That opposite is 78 and change. You okay with that? I know that. The 120, because we went 20 knots an hour for 6 hours. The hypotenuse. Okay. So you have the 120 for this triangle here, the 29 degrees here. Can we figure out this distance, the southerly distance that they went? Think back to the trig. If you're at 29 degrees, you have your adjacent and a hypotenuse. What do I use? Cosine. It wants to know this diagonal, how far away you are, and what's your angle. So we had to go back into the first triangle that we created to find the adjacent side, because we know the opposite for the big triangle. So 120 cosine 29. $104.95. the diagonal distance is easy. All you have to use is Pythagorean theorem. Oops. But to get that theta, that angle that you are from port, what trig function am I going to use with my opposite and adjacent? Tangent. Remember how to use that in the calculator to find the angle? Use the inverse, the arctan. And then you just use your arctan or inverse tangent to find theta. So second tangent, 78/18. 36.68 degrees. So you are south 36.68 west. If you want to be fancy about it, because you're still in that quadrant space over there. Nautical stuff, it takes a little getting used to the bearings, to be honest. But we're going to be doing this stuff for the next 2 days. So. And then it takes a little getting used to. Just remember how if it's written out like that, you will do a little bit of nautical stuff. Like if you say you're going at 10 knots or nautical miles per hour, they might say you're going for 4 hours. You might have to do 4 times 10. Little things like that. Sir. The arctangent? One of the questions in there was, what was the angle it was from port? So the angle, what angle did it go from port? Well, using this in that same quadrant, so we're still in that south angle west. It's south 36.68 west. Or I don't remember if it's minutes, but okay. Like I said, we're going to do this for the next few days, so I've got a little bit more of the problems than you probably want to see, but I'm not. You got like today, tomorrow. Oh, that's right, Saturday and Sunday to get all this stuff done. So that way we can work on them again tomorrow. Because some of you guys will go through this stuff a lot quicker than others, which is fine. A lot of those that it's like 15 through 40 all, we've done 3 of them already. The silo, an angle of depression one, and the bearing problem. Some of those angle depression ones are, you're in a submarine with an angle of depression of so much, how deep are you? So they're really fast, quick trig problems. It's just a matter of drawing a picture. Okay? You guys are great at drawing pictures.
Especially when we use these.
The page in the book this starts on is 359.
Got the page.
Okay. And like I said, we'll do this for